And welcome to 3.4, Equations and Graphs of Polynomial Functions. By the end of this lesson, which will probably be in 2 or 3 different videos, rather than having one super long one, we'll chop it up a little bit. By the end of this lesson, you'll be graphing, really sketching polynomials. It's pretty crazy, the kind of stuff that we're going to get done in just a little while, figuring out how to graph really complicated polynomial functions. So first of all, let's do this first example. It says example 1a, determine the zeros of the following cubic function. And just by the way, I didn't make these notes. You can write zeros with the e or without the e. Either way is fine. I think I end up writing it without the e. But in any case, determine the zeros of the following cubic function. So what are the zeros? Well, first of all, the zeros are from this one, 2, -3, and +1. So what are zeros? First of all, you can think of zeros as, if you were to graph this, it's where it crosses the x-axis. Okay, so crosses x-axis at these points. It's also another kind of a definition is the x values at which y is equal to 0. So, oh, sorry, x value, that's right. So if x is 2, then this term becomes 0, and thus the whole thing becomes 0. The second part says determine the y-intercept of the function. Well, if we were just given this definition of f of x, we would say use the constant. So it is +6. And so the two ways you can look at it is the constant term, or if it's given to you in factored form, like if it's given to you in this form here, what you can do is plug a 0 in for x. All right, so this is the y value when x equals 0. So when x equals 0, really you're multiplying -2 times +3 times -1, and you get that +6 again. So there's that two ways of looking at it. Summarize what we know about this function. Well, first of all, the function is odd. Not odd as in funny looking, but odd as in the fact that this is of degree 3. So I'm going to say odd. I'll put in parentheses 3 to say that it is of degree 3. The leading coefficient is this 1 here. It's a +1. So I'm going to say it is positive. Maybe I'll just shrink this down so we can keep track. The end behavior. Well, looking at these two, if it's odd and it's positive, this is a possibility for the shape. It is definitely going to be going, maybe I'll start from the left, down in quadrant number 3 and up in quadrant number 1. The zeros of the function, we already figured that out. I'm going to go from smallest to largest. I will start at -3 and then 1 and then 2. So really I took these values here and I just reordered them so that they are from smallest to greatest. The y-intercept we figured out was +6. Now it says intervals in a sign diagram. Well, if we take those zeros, if we were to go like this and put a -3 and then a 1 and then a 2, to the left of -3, what is the sign going to be? Well, kind of looking at this down in quadrant 3 idea, this has to be negative here. Okay, we can't automatically assume, and we're going to see why in a second, that this is going to change signs. So here's what it will do. We won't necessarily do this every time, but if I write it out, I'll go maybe off to the right. If I write this term out in factored form, x minus 2, and then x plus 3, and then x minus 1. And we're going to make a little bit of a chart here. And then here, so all And I'm going to consider what happens over different intervals. So the first interval, I guess to the left of the -3, that first interval, interval here, would be between -infinity and -3. I think this interval notation is so much easier to work with. So if I put in a very large negative value, so imagine that x is a very large negative value, this term will be negative. All I'm thinking about is, will it be negative or positive? If I put in a very large negative value in x plus 3, it'll still be negative, and again it'll be negative here. So what happens to all these three when I multiply them together? A negative times a negative times a negative is negative, and that's why I know that this should be negative in that interval. Okay, so my next interval is between -3 and +1. So perhaps let's just pick a number that is between -3 and +1. How about 0? So if I put 0 in, you can think of a 0 here. This will be -2. So this part will be negative. This term will be positive. This term will be negative. And what happens when we multiply a negative times a positive times a negative? We get a positive. So we know that between -3 and -1, it will be positive. How about between 1 and 2? So in other words, the interval between 1 and 2, well, let's think about 1.5. Okay, so it's a little bit harder. 1.5 minus 2 will still be negative. 1.5 plus 3 will be positive. 1.5 minus 1 will be positive. So here we get a negative times a positive times a positive, so we get a negative. One more interval to do, that's between 2 and positive infinity. So a very large positive number, this will be positive, positive, and positive, and so we get a positive. So this is the interval sign diagram here. This column just really gets transposed over here. So this is negative here, as we found out, and that's positive there. I hope that this was helpful. I don't really write this out every time, but this really explains in detail what goes through my head, I guess, when I'm making this sign diagram. Okay, so now it's about time to sketch the graph. All right, so I would put in the zeros first. So just like this line over here, we got a -3 here. We have a +1 and we have a +2, and then the other one we want to think about is this y-intercept over here. We got this y-intercept of +6, so we'll put in a +6 maybe up over here, +6. And now we're going to be crossing the line here, going up, and then when we come down we cross +6 because it tells us that, and then it's still positive. We cross 1 and we're in the negative zone. Try it again. We cross 1, we're still in the negative zone, but then we got to go up here. Okay, so thinking about the fact that it has to be negative over here and positive and then negative, there we go. Now notice that we say sketch the graph, which is a little bit more loosey-goosey than saying, you know, make a detailed graph. This is all that we need to get. A couple of things. Note, we don't have to worry. So like here, here, and here. Don't worry about knowing the maximums or minimums. If you had your line go up and say you drew it so that the maximum was at 6 and then came down, like that red line, I just did a really ugly red line. If you did one like that, that would be fine. Don't worry about making it look exactly right. Okay, I'll just clean up. As long as you're hitting this spot, as you're hitting that spot, that spot, that spot, and you're, you know, here it's all positive and there it's negative and there it's positive again. We're looking for the shape. In fact, finding out the maximum and the minimum, that is easy peasy when you're doing calculus. We are in pre-calculus, and so we don't have to do it at this stage. Okay, so next page. It says, and we're going to, basically, that's what we're learning. That's the lesson. That was the first example. Now from here on, it's just doing a few more examples and learning a few more details in how to do this. So here it says, determine the roots of the following equation. Well, what's the difference between example 1 and example 2? This one isn't factored, so we're going to have to factor it. Okay, so I'll put it in factor, exclamation mark. So the first stage about factoring, this is yesterday's lesson or the last lesson. Let's take a look at the constant term 4 here and we'll say, okay, well, what are all the possible factors? Plus or minus 1, plus or minus 2, and plus or minus 4. So really there's only 6 to go through. We're going to use the remainder theorem. Let's test for x minus 1 first of all. In other words, I'm going to put 1 in for x in that polynomial p of x. So I get, it's nice to do a positive 1 because all I got to do is worry about these coefficients. So it's going to be negative 1 plus 4 plus 1 minus 4, which is equal to, hey, 0. I got one right away. So I know that negative 1 is a factor. Instead of carrying on and doing the rest of these, I'm going to use synthetic division to factor out the x minus 1, and then it'll be a simpler polynomial to work with. So again, I'll put the negative 1 plus 4 plus 1 minus 4. I'll use synthetic division, and remember we're going to be using that 1. So bring down this negative 1, multiply it out. Add these two together, I get 3. Multiply that times 1. Add these together. Multiply by 1. Add them together. Good, just sort of my check here. Good, I got a remainder of 0. And now I've got negative x squared plus 3x plus 4. If you're like me, I find it a little uncomfortable to have that minus x. I'd much rather have a positive. So what I'm going to do is factor out a minus here, and then everything inside changes sign. Now that's so much easier to factor. Thinking about this, I need two numbers whose product is minus 4 and whose sum is minus 3. So I will get two numbers, what would it be, negative 4 and positive 1. When I multiply them together, I get negative 4. When I add them together, I get minus 3. We're good to go. Okay, so this whole thing, I should put this together then. In factored form, it'll be minus, what will I do? Maybe I'll start with the x plus 1 term first, and then I'll put the x minus 1 term, and then the x minus 4. The reason why I did that is because then I can figure out the zeros, which, by the way, is the exact same meaning as roots. The roots or zeros are, so here it's going to be negative 1, positive 1, and positive 4. So I just put them in this order, thinking ahead that I wanted the zeros from least to greatest. Determine the y-intercept of the function. So if I plug in a 0 for x, here I'll just erase this, if I plug in a 0 for x, I would get minus 4. So the y-intercept is minus 4. Summarize what we know about this function. Okay, the degree is cubic, so it's odd. It's of degree 3. The leading coefficient is negative. And so the end behavior, well, when I've got an odd one that's negative, I guess the basic shape often looks something like that. So I would say it goes up in quadrant 2, and it goes down in quadrant 4. The zeros are negative 1, positive 1, and positive 4, and the y-intercept is minus 4. When I draw my sign diagram, I'll use those zeros, negative 1, plus 1, plus 4. It's going to be, because looking at this shape here, it'll be positive here, and then between here and here, it'll be negative. There it will be positive, and then it'll hit negative again. So you see, up until this point, we've seen every time there's a 0, the sign has been changing. That won't always be the case, but we're going to be investigating when that isn't the case coming up. So at this point, we can safely think, okay, the sign will be changing. And if you're not quite sure, like I did on the last page, you can make a nice little chart and figure it out. Okay, let's sketch the graph. So some semblance of a scale here. I'll make a minus 1 here, a plus 1 here, and let's well, there, maybe let's pretend that this is about 4 times as far out, so that's my plus 4, and my y-intercept was minus 4, so I guess I'll make it down there, minus 4. And so to get that same kind of a shape, I'm going to be going like this. Do I know that minus 4 is the minimum? No, I don't. It could very well be something different than that. Do I know that the maximum is only about that high? No, I don't. But I definitely know this general shape of it. And so that's what we need to do the sketch. Okay, multiplicity. You know what? I'm going to stop this video now just in case you need to get a break. I'll upload this one, then I'll go to multiplicity.